So good morning, guys. I'm Tanawat. So today I'll be taking you through the problem set, the second one with question 6 and 49. So let's get started. So for the question 6, it says find a point P in the first quadrant on the curve y equals to x to the power of -2, such that a rectangle with sides on the coordinate axis and the vertex at point P has the smallest possible perimeter. So what can we get here from the equation? So it says that curve has the equation of y equals to x to the power of -2. And then next we need to find the rectangle perimeter. So the equation here for the rectangle perimeter is 2x plus 2y. So next we need to plug in the curve equation into the rectangular perimeter. So it is 2x plus 2x to the power of -2. And next what we need to do here is to derive the rectangle perimeter equation to find the smallest possible perimeter. So it's d regarding to dx perimeter equals to 2x plus 2x to the power of -2. Since perimeter is a number with no variables, so after the differentiation it will be 0. So 2x is equal to the cube root of 2. Or you can write it as 2 to the power of -103. And now as we already got x, we need to plug in the x into the curve equation to find the y. So find y is 2 to the power of -2 over 3, or we can write it as let's say 1 over cube root of 2 to the power of 2. And that's it. Or let's say the point P for the clearer answer, 2, 1 over 3 on 2. And that's it for the first one. And next, let's proceed to the next one. Number 49, it says the lower edge of the painting is 10 feet in height, 2 feet above an observer's eyes level. Assuming that the best view is obtained when the angle sub 10 at the observer eyes by the painting as maximum, how far from the wall should the observer stand? So let's illustrate the picture first, so we can see like a clear picture for this equation. So let's say this is the painting with the height of 10 feet. Let me use another color. 10 feet. And it says that and it says that it's 2 feet above an observer's eye. So 2 feet. So let's say the observer is here. So here's the distance between the observer and the painting. The first one, the first angle here, I will denote it as theta 1, and the second angle here is theta 2. So what we need to find here is the subtended angle between the observer and the painting, which is here, theta 3. So let's formulate the equation from this picture. So to solve for the theta one, we can come up with the tan. And next we need to formulate an equation to find the subtended angle. So let's say the x3 is equal to x2 minus x1, theta 1. And next we just plug in and now what we need to do next to find the maximum is to go for differentiation. So let's say theta 3 diff is equal to So here's regarding the derivative rule, here's the derivative for the arctan. So let me take a screenshot. And let's plug everything in. So it says that 1 over 2 12 d negative 1 square. So don't forget the chain rule is negative 12 d to the power of negative 2, and then 1 2 d negative 1 to the power of 2, and chain rule again to negative 2 d negative 2. And next we need to solve everything. So now we got two equation here. So let's solve for the first one. So it's 10d to the power negative 2 equals to 0. So it's d to the power of square. So regarding the limit theorem, d is equal to infinity or undefined, which is unusable here in this equation, since the distance can't be undefined. So let's solve for another one. So 2 to the power of 6. I mean 2 with the square root of 6. And that is our answer in feet.